Okay, 11.7. This begins on page 642. And we're talking about the surface area and volume of cones. Like this. I'll stand over here while I talk about this. But like I was just saying a second ago, they don't, the authors of this book, this is the only thing they want you to be able to find the surface area. Stupid, but I'm going to go with the book, and the next time I teach this, I might add in the things that are necessary, because we've not been trying to figure out how much it costs or how much it takes to paint, for example, to paint a cylinder, like a can. We haven't talked about that. That would be surface area. I haven't talked about that. We've talked about filling them. We haven't talked about how much it takes to paint or cover or maybe wrap with paper a box, which is called a prism. We haven't talked about any of that stuff. And we probably should have up to this point. But we are going to talk about how much it takes to paint this thing, including its base. So the base is pink. And since we haven't talked about surface area, this is going to be a new term for you. The yellow stuff on this, just like the label on a soup can, you know, the Campbell soup can, if you were to cut that off and hold it out, it would be a rectangle, right? Those things, without regard to the bases, just this stuff, like the yellow part of this, is called the lateral area. It's the wrapping. Not the top and the bottom. It's just the stuff in between. They call that lateral area. And so we're going to learn how to find the lateral area of this, which is just the yellow stuff. And if we want the total surface area of the cone, we will also add on to that a pi r squared, because the base of a cone is a circle. Okay? Yep. And it turns out, and I would develop it for you, but people forget it anyway. They say, yeah, I saw it proved one time, and I believe it's true. You can believe it's true. The surface area of this is a super easy formula, the yellow stuff on this. It is. I'm just going to hand it to you so you can use it. The yellow part of a cone. The yellow part of the cone I was talking about. So it's the pointy stuff that wraps around. It comes to a point, and that surface area, just that part, not the base, is the, I'm going to say the lateral area, that stands for one variable, is equal to pi r L. And L is what we refer to as the slant height of the cone. That is not the height. The height of the cone is an imaginary line which is dropped right down to the center of the circle, perpendicular to that base. That's the height. But this part of it is the lateral height. You with me? Mm-hmm. And then this would be the radius, and the three together make a very nice, neat right triangle, which we know a lot about. So there's going to be lots of right triangle stuff that you have to deal with today, whether it's trig, special right triangles, Pythagorean theorem, whatever it calls for. And this right here is the radius of the base. That's the r. And the slant height is this length right here, which is the hypotenuse of this triangle that I've drawn. So the total surface area means the whole thing, if you're going to paint or cover the whole thing with something, would be the lateral area plus the base, which is a circle, and its area is pi r squared. Good? Okay. So that's total surface area or lateral area. It depends on what they ask for and how far you go. Now, take a look at, we're going to see some variations on this. If you take a look at example 1, they give you everything you need there. It says, find the surface area of the right cone. What does right cone mean? It means that if you were to connect the tip of it, the pointy part of it, to the center of the circle, it would form a right angle. A non-right cone would be something like this. Because when you drop that down there, it does not hit the center of the circle. So this is a right cone, which means you can count on the radius and the height to be perpendicular and hit at the center of the circle. So we got ourselves a nice right cone, and they give you the information. It's just written right on the picture. The only thing we need to find the surface area, if you'll take a look, all we need is the radius, which is used twice, and the lateral length, the lateral slant height, the thingy that they call it. If you look at that picture, we've got it all. It's just sitting there waiting to be used. You with me? So example 1 is going to be the surface area. I'm just going to write it down. And I would recommend you do this, if for no other reason than every time you write it down, you'll commit it to memory a little bit harder. Will stick in your memory a little better. I suggest you always start out with a formula and then fill in what you can. That's what my strategy this whole chapter. Pi, radius of this thing is 4, and the slant height is 6. So it's going to be pi times 4 times 6 plus pi times 4 squared. That's 24 pi plus 16 pi, which is 40 pi, I think. It's fine to leave it in terms of pi, unless the instructions say round to the nearest hundredth or something. Then you got to work the pi in and round the number. But if you want, you can leave it in terms of pi, or you can give me a decimal answer if it doesn't indicate it. I'm going to leave mine in terms of pi because I like exactness, and besides that, I don't want to calculate. And it ends up being, because they gave it to us in inches, keep in mind what this is. We're finding surface area, what it takes to paint it. So this is in square inches, not cubic ones. Because we're painting it. It's paper that it takes to make the cone, and that's in square inches. Do you understand what I'm saying? Mm-hmm. Surface area, anytime anything has to do with area, the units will be squared things because area is measured in length times width. 2 dimensions. Got it? Okay. So that wasn't very hard. Now we're going to talk about the volume of a cone. We've got the surface area, which is right here. These two things have to do with painting something. This has more to it than this. And the volume of a cone, just like the pyramids that you worked with yesterday, is going to be 1/3. I would pour it out for you and do it again, but it's going to be exactly the same thing. Things that come to a point like this are 1/3. They hold 1/3 what you would have if you didn't bring it to a point. So if you had the cylinder right here and somehow you were able to just scoop it all together into a point, this new thing will only hold 1/3 as much as this. And the volume of this, if you'll remember, was base area, which was pi r squared, h. It was how many of these we had stacked up. Remember when I did that with the quarters? Mm-hmm. And so the volume of this, if you'll remember, is pi r squared h. So the volume of a cone will be 1/3 pi r squared h, because it's a pointy thing instead of a cylinder. It's no harder than that. Okay, so it's just like a cylinder, just divide it by 3 when you're done. It involves the very same thing, the radius and the height. And please keep in mind that the height here is this one that goes from the center up, or at least the distance from the tip to the base, whatever that is. Even if it's on a non-right, the one that I erased, even if it's on a non-right cone, if it was like the one I had before, if I had it dropping down like that and over, if I knew that this was perpendicular, then this would be the height. It's the distance from the pointy thing to the base. Wherever it is, it doesn't have to hit the center. That's only on a right cone. It's the distance from the point to the base. That will be the h on this one. So let's try that. Example 1, find the volume of the cone. And notice it is a non-right cone, but it's very clear that the height is 4.5 and that the radius is 2.2. So we just plunk it in there. This is example 2. And we have volume. Well, I suggest you write it down. And then fill in the gaps. Pi is just a constant. R in this case was what?
2.2.
2.2 squared, and the height was
4.5.
4.5. You grab a calculator, you type it in just like that, and you'll be golden. Leave the pi out if you want, and just multiply these numbers together, and then slap a pi on the end. You'll have an exact answer. Do you know what I'm saying? Just leave the pi out of the calculation, put pi on the end of it, and you'll have it. If you want to work the pi in, then you'll have an irrational number. Just round it to the nearest hundredth or so. So I don't do that with decimals that well, so let me see what we got. If you type it in your calculator, this would be the syntax. If it were me, I would go parenthesis 1 divided by 3, stick a pi on there, or don't. I think I'm going to leave mine off and put it on at the end. Put another parenthesis, 2.2, close it, square it, open another parenthesis, 4.5, and then put it, well, if you're going to calculate, we'll put the pi on the end in just a minute. So I'm going to go 1, parenthesis, 1 divided by 3, close it, another one, 2.2, close it, squared, open another one, 4.5, close it, gives me 7.26, but don't forget the pi. 7.26 pi, and then we look for units, and the units are centimeters, so this will be what? What will it be measured in? Anybody?
Centimeters.
Centimeters? Cubed, because we're talking volume. If you wanted to multiply that by pi and you wanted to work the pi into it, that'd be fine. That would be the same thing as 22.81, about. Either one's fine, unless they say in the instructions how to answer it. They may say, leave your answer in terms of pi, in which case this is the only acceptable one. They may say, round to the nearest tenth or hundredth, in which case this is the only acceptable one. If they don't say, I'll take either one. Yeah? You good?
Yep.
Cool. Moving on. Take a look at example 3. Go back to doing those things that are similar, and trying to come up with the correct proportions. So listen to what it says. And this one it says cone A and cone B are similar. That has to be the case. So they'll always tell you that if they're going to do this kind of problem. And it says find the volume. So that's the operative word there. Find the volume of cone B, which means we're going to have to take the scale factor and cube it. Had it said find the surface area of cone B, we would have taken the scale factor and squared it. You understand? Because area is squaring, volume is cubing. We're doing volume here, so we're going to cube it. So now we look for something in the picture that tells us two linear things that are the same and how they compare. In example 3, those two little cones compare in a ratio of 1 to 3 if you reduce the scale factors, 3 to 9 with the radiuses. Those are linear things. And so we're going to use 1 to 3 for our scale factor. You with me?
Yep.
Okay, so this is by reducing that fraction, I have 1 to 3 for my scale factor. If I cube that, I get 1 to 27. Keep in mind, that's little to big, so you have to put your proportion together the same way. So, I mean, your ratios. 1 to 27 as, now I look for the one volume that they gave me, and the volume they gave me was the little one, 15 pi. So it goes up here. And the volume of the big one is what I'm seeking. But I have to use this ratio, not this one. It has to be the cube of it.
Why did you keep the 1/3?
Because we're doing volume comparisons.
Oh.
Scale factor is linear. If you cube that, because volume is a cubic thing. If you cube the scale factor, it gives you the volume factor.
Okay.
And that belongs in my proportion because I've got volumes over here, actual volumes over here, and a ratio of volumes over here.
Okay.
This is a ratio of sides or a ratio of linear things. I need a ratio of cubic things. You understand? That's why we cube it.
We could square it and give us the area.
Yes, if they ask us, if the thing was involving surface area instead, and had these two, then I would have just squared this and I would have been using 1/9 here. And the area is over here.
Okay.
With me? Yeah. So I get 1 times V is V equals 27 times 15 pi. What's 27 times 15? 405? 405 pi. What?
Feet.
Feet, is it? Oh
Yeah.
my goodness, that's a huge cone. So that many pi cubic feet, if you wanted to make a decimal out of it, you would take that times pi. I'm not going to write it down, but just take that times pi and round it to the nearest hundredth or so. I'm leaving mine in its exact form since they didn't tell me. Did they tell me?
No.
Nope, just find it. So either form is going to be great. Do you understand how to handle the similar objects and their volumes and surface areas?
Yep.
All based on the scale factor. Whether you cube it or square it is depending on whether you're talking about areas or volumes. And this one was volumes again. We good?
Mm-hmm.
All right, one more thing. Example 4. Told you it wouldn't take that long. Example 4 is a composite solid. It's made up of a cylinder and a cone. Okay.
Mm-hmm.
Please notice that the cylinder and the cone both have the same radius. And so even though they didn't give me the radius of the cone, I know it's 6. Y'all see that? It also gave me the height of the cone and the height of the cylinder. So I got everything I need. They want us to find the volume of this composite solid. And so if we follow the strategy that I've been asking you to do all along, I guess I'll erase this. We put together what it is we want to find the volumes of. And there's two different shapes here. So I'm going to say volume of a cylinder plus the volume of a cone. That's what I intend to add together. And the the formula for the volume of a cylinder, remember, that's this one right here, is pi r squared h. For a cone, it is 1/3, times plus 1/3 pi r squared h. I would get 4/3 of these because this is one whole thing plus a third is 4/3. I wouldn't do that because sometimes the radius and the height for the cylinder are different from the radius and the height for the cone. And if you just added them together, that would be assuming that these were both the same for both of them, and they aren't in this example. So don't cram them together because this R and H and this R and H may be different. Just plug in what you can see. So for the cylinder, I've got an R of 6 and an H of 5. Because the cone sits right on top of the cylinder, which we observed just a moment ago, this is still 6. But the height of the cone is not 5 like the cylinder is. The height of the cone is 4. So you got to get the information pertaining to whichever one of these you're trying to fill in. And then we just get after it. 36 times 5 is 180. You understand what I did there? You gotta square things before you multiply. Get 180. This one over here is gonna be 36 times 4, which is 144. Ooh, divided by 3 is what, 48? 36 times 4 divided by 3, that's what this is going on right here, I think is 48 pi.
Yeah.
Okay, when I add the two pi's together as like terms, this is going to be 228 pi. And it will be whatever the units were. Meters. Oh my gosh, that thing's huge. Meters cubed. Because it's volume. That's what I was adding. Everybody see? So if what we're doing here is following the same strategy we've always done. What two things we got to find? This, write down the formulas. That should start, I hope, very soon that'll come from your memory. You don't have to look it up. Then fill in the gaps. Find the cylinder's radius and height. Find the cone's radius and height and put them in where they go. And then start out on the arithmetic. Once you get these all filled in, you could actually grab your calculator and just start typing if you really wanted to. I think I would simplify some of the arithmetic because you're likely to make a mistake at the calculator with that much stuff. You know? But that's it. That's all there is to this. Surface area means you're going to paint or cover this. Volume means you're going to fill it up. Make sure you're using the appropriate formula and memorize them. They are right here. Lateral area is everything but the base. It's just the pointy part. Surface area adds the base to it, and the volume is just a third of what a cylinder would be. You got to have those committed to memory before test time. You do not get a cheat sheet for this. Ready for the assignment?
Yep.
Wow, you got a long time. You should easily be able to finish this. It is 3. It's just a list, okay? So just put commas between everything. 3, 4, 7, 8, 11, 13, 14, 19, and 20. That's 9 problems. Not going to be too bad. If you need some help with it, though, let me know. There may be some things that you encounter in the exercise that I did not touch on in this lecture. If that's the case and you don't know how to handle it, let me know and I'll help you.